Sustainable photoactivated catalysis. The intention is to make particles that are catalyst particles photoactivated with some form of light UV visible. Markets include ones where biodegradable particles could be useful for things like oil slick cleanup. The intention really is to provide floating particles where nanoparticles can coat, and we can use the advantages of the nanoparticles around the surface, and that they can be used for hydrogen production and water treatment. The technology really rests upon the ability to create a drop which floats on water, for example, and to coat that drop with the nanoparticles that have the photocatalytic effect around the outer surface. So we could have water with pollutants in it, and the presence of oxygen and UV light and water at this stage here would destroy the pollutants in the water. We've proved the principle in the laboratory stage. Here we have blue dye before, here we have the clear water after. It's the same dish in which we ran the tests. Here are our floating particles still there. There's the titanium dioxide. Our expertise is membrane emulsification, which we use to make these floating particles. What we need to do is to scale up from the bench tests into processors. We have some contactor designs which we're currently looking at patenting, which will enable the recycling of these photocatalytic particles. Commercialisation, we'd like to make the particles in the UK, and we'd license the technology. We'd like to work with other nanoparticle catalyst users so that we can easily recycle the catalyst particles. And as far as an impact, lower energy costs for water treatment, less waste. You're not using adsorbents, we're destroying the pollutants in situ. Obviously environmental clear-up. We need to finance a temporary worker to work full-time on this, and of course to generate interest in the technology.